All right, let's jump right in and talk about the absolute nightmare that is orchestrating multi-agent AI systems. Look, if you spent any time at all building with AI, you know exactly the kind of pain I'm talking about. Picture this. You spend hours, maybe days, meticulously tuning a prompt. You finally get it working locally. You push it to staging, and everything looks golden. But then, a tiny upstream change happens. Maybe the language model gets a silent update, or a parameter shifts just a fraction. Bam! Your entire downstream pipeline shatters like glass. So today, we're looking at a system that promises to cure this brittle glue code epidemic once and for all. We're talking about replacing those awful late-night pager alerts with actual, rigorous software engineering. So here's the stark contrast we're dealing with. The painful reality of hand-wired, fragile systems on one side versus the promised land of statically validated workflows on the other. Because let's face it, the industry's kind of stuck right now. Building multi-agent pipelines usually means hacking together these rigid systems that just snap under the slightest pressure. And the absolute worst part? The silent failures. In traditional software, a failure usually screams at you with a loud 500 server error. But in AI, a silent failure means the LLM returns this beautifully formatted JSON object that is literally full of hallucinated garbage, and your system just happily passes it right along to the user. Well, we're diving into a tool designed to help you escape that trap completely, catching those failures way before they ever execute. Honestly, if you've ever built an AI agent, you've probably lived this exact quote. It perfectly sums up the tragic life cycle of modern AI development. You build a prototype, it looks absolutely killer in a demo, and then the very first real-world change completely breaks your hand-wired connections. We're looking at a massive graveyard of silent failures here. A single misunderstood prompt doesn't just throw an error, it can confidently bring down your entire production environment by feeding totally bogus data into a critical database. It's really time we fix this deeply flawed foundation. Here's our roadmap for today. We'll start with the AI project graveyard, then look at the solution, Workflow Builder. After that, we'll walk through the 4-step magic loop, break down the hexagonal architecture, cover pre-flight checks and publishing, and finally, getting ready for production. Let's get to it. First up, the AI project graveyard, and why exactly our prompts keep failing in production. This really frames the ultimate engineer's dilemma. When you're building software, you're usually forced to pick your poison between two equally terrible extremes. On one side, you've got exhaustive specs. Think old-school waterfall methodology, spending weeks writing massive design docs before you even know what you're building. That is way too slow for the fast-paced world of generative AI. On the other side, you just write brittle glue code. You embrace the whole move fast and break things mantra, which in this case is essentially agile gone horribly wrong, giving you systems that break on the very first change. But this AI workflow builder finally gives us a third option, a system that's statically validated for absolute safety, but still incredibly fast to build and iterate on. Which brings us to the solution, the workflow builder, and how we actually escape that graveyard. So how do we actually pull this off? This tool is super cool because it takes a plain English or even Chinese prompt and transforms it into runnable Python orchestration code without any of the usual guesswork. The real secret sauce here is the output, a DAG. That stands for Directed Acyclic Graph. Now, why should you care about that? Well, directed just means the data only flows one way. Acyclic means there are absolutely no cycles. By forcing your AI workflow into this acyclic graph structure, you are mathematically guaranteeing that your agents will never get stuck in an infinite loop, meaning no more waking up in a cold sweat to a massive OpenAI API bill, just because two of your agents decided to talk to each other all night long. Moving right along to the 4-step magic loop, taking us from a simple prompt all the way to finished code. Let's trace the journey your prompt actually takes here. It operates a lot like a high-tech factory assembly line. First, raw, natural language comes in at the start. You just define your goal and your inputs. Simple enough. Then, that raw intent gets fed into an interactive feedback loop to relentlessly refine it. Next up, it hits the structural integrity test, running through extensive static pre-flight checks. And finally, out the other end comes ironclad generated Python code. It's a really seamless process that takes all that inherent vagueness of human language and just distills it down into the strict, predictable logic you need for enterprise software. I've got to say, I absolutely love the Grill Me loop. Think of this step like dealing with a hyper-pedantic project manager who absolutely refuses to let you write a single line of code until you explicitly define what "do the thing" actually means. Instead of finding out your prompt was vague 3 weeks later when it crashes in production, this system literally interviews you on the spot.
It resolves only what is genuinely ambiguous, forces you to nail down those success metrics and edge cases right up front, and then saves the whole thing to an auditable, version-controlled YAML spec. That YAML file then becomes your absolute single source of truth.
All right, for my fellow developers out there, let's lift the hood and talk about hexagonal architecture. This is just a beautiful example of hexagonal or ports and adapters architecture. The best way to visualize this is to think of a household appliance. The core domain layer is the appliance itself, right? It holds the pure business logic, the grill engine, the DAG model, and it has exactly 0 framework dependencies. Now, the adapters are like the different types of wall sockets you find around the world. The appliance itself doesn't care if it's plugged into HTTP, Express, or SQLite. The application layer just steps in and translates the current. Because this core domain logic is entirely decoupled from the database and the web server, it is insanely testable. Running a full domain test suite on a bare checkout in mere milliseconds without having to install a massive black hole of node modules, that is literally a developer's dream. And in an era where it feels like every single new tool out there just wants to siphon your proprietary data into their cloud, you'll be thrilled to know this is a fully self-hosted studio. It's a standard Node.js and React monorepo that you run entirely on your own local machine. But here's the best part. It uses an envelope-encrypted vault for your OpenAI or Anthropic API keys. Basically, a data encryption key encrypts your provider key, and that is wrapped by an environment key encryption key. The bottom line, plain text keys are never, ever exposed in any HTTP response. You could literally take this architecture, pitch it to your ultra-strict enterprise security and compliance teams, and actually get a yes without being laughed out of the room. Your keys stay yours. Moving on to pre-flight checks and publishing, and how we actually ensure production safety. These static AST-level checks are the real secret weapon here. And crucially, nothing executes on the server during this phase. It statically checks the DAG for cycles, so you don't accidentally build one of those dreaded infinite loops. It verifies node reachability, which catches logical dead ends before your agent has to try and hallucinate a way out of them. It makes sure schema parameters perfectly match between your connected agents, so you don't get hit with runtime type errors. It enforces strict tool boundary constraints against an allow list. And critically, it validates security boundaries to straight up refuse any executable payloads. Because of this rigorous pre-flight checklist, you get exact, pinpointed violations right in the studio instead of some mysterious silent failure 3 weeks down the road. And when the generator finally finishes, you aren't just left with some flimsy, fragile script. No, you get a completely scaffolded, enterprise-grade repository. You're getting fully typed Python interfaces, so your IDE actually autocompletes properly. You get built-in LLM retry and fallback logic right out of the box, which alone saves you hours of writing boilerplate just to handle API rate limits. You get GitHub Actions, CI wiring ready to go from day one, and of course, your scaffolded spec files. Plus, if you happen to be on the team tier, you can bypass the manual setup entirely and just publish the whole thing directly to a fresh GitHub repo with a single click via OAuth. It's incredibly slick. Finally, let's talk about getting ready for production and the ultimate bottom line here. 688. That is the number of real-world, battle-tested automations successfully orchestrated using this exact system by the /man413 team. So we're not just talking about some theoretical academic exercise built in a pristine vacuum. This is deeply hardened infrastructure. It was designed from the ground up to actually handle the friction, the weird edge cases, and the sheer chaos of real-world multi-agent systems operating in production at scale. Now, I want you to frame this against the absolute cost of your developer time. Seriously, how many hours do you spend in a given week just debugging a single glue code failure? At an introductory launch price of just $99, this tool easily pays for itself the very first time one of those static checks catches a production error before you ship it. It's a one-time price that gets you the self-hosted studio with an MIT license, which is huge, meaning you can use it commercially, modify the source code, and ship it. There's even a 30-day money-back guarantee, so the financial risk is basically zero. And looking at this timeline, this is where the true value proposition really hits home. Minute 1, you're just typing out a vague idea. Minute 2, the system is forcing you to be precise, grilling you for those edge cases. By minute 3, you are visually checking your mathematically validated DAG, knowing for sure there are no loops or dead ends. And by minute 4, you're exporting a robust, fully typed Python repo. It is a complete game changer in terms of workflow speed. We are talking about going from a napkin sketch to ironclad architecture in under 5 minutes. So I'll leave you with this question. Are you going to keep duct taping your AI systems together, just constantly waiting for that inevitable late-night pager alert when an LLM provider slightly tweaks an API spec? Or are you ready to finally treat AI orchestration with the actual software engineering rigor it desperately deserves? The tools to stop hacking and start engineering are right here.
It is definitely time to stop building brittle glue code and start building real architecture.